Okay, welcome to Communication System 1. This is a ECC 1015. And here's a brief introduction of a course outline. So we have a course time on Monday and Thursday. Monday 2:30 this time and Thursday 9 a.m. I have office hour on Wednesday at 1 p.m. to 3 p.m. So if you want, you can come by my office anytime during this hour. Or you can send me an email if you want to set up an appointment in another time. So here's my information. Email is the most preferable contact information. So you can send me email anytime if you like, if you have any course related questions. And here is my room. Okay. We have two textbooks. As I said earlier, this is going to be the main textbook. So if you already have this book, that's okay. Or this book is also fine. We have these two books pretty much have the same common information. And also, sometimes one chapter here is in another chapter there. But basically, it's a little bit different order. So basically, it's the same information. So either one is fine. This course has prerequisites. ECC 308, this is a signal and systems. So you learn some of the basics, signals or convolution, some signal-related information or some procedure and those things in this course. And another prerequisite is a random variable. This course is very important for this course because this course that we are doing, this is one of the basic courses for communication, wireless communication or some telecommunication course. And in wireless communication or communication course are somehow related to the mathematics. And out of many mathematics, we depend on the random variable or some probability, stochastic theory, and those things. So this course is actually very basic and very important prerequisite of this course. But if you didn't take this course, or if you are not very familiar with this course, that's okay. Okay, we can learn throughout this course. We're going to have a couple of homeworks throughout this course, and some of the homeworks will be based on the MATLAB and Simulink. What that means is we have two different types of homeworks. One type is like a handwritten kind of traditional homework. Another type is that I like to ask you to do some simulation. So you probably write your own code based on the MATLAB or maybe C language if you like, or any other tool like a LabVIEW if you like. So you can use any other tool, but basically I'm assuming that most of you are using MATLAB. And based on this tool, you can write your own code to do some simulations, okay, to run some algorithm. That's going to be another type of homeworks. Probably within this course, maybe 2 or 3 such kind of homeworks. Okay? Not that every week, but probably 2 or 3. Here's a grading. We have a midterm 30%, final 30%, the major chunk. And we have a 20% of homework. So remember that we have a pretty high percentage for homeworks. Okay, so homeworks are very important. And quizzes here, you don't have to worry much about the quiz because this quiz is very different from other courses. Maybe other courses in the quiz, it's almost like an exam, right? 30 minutes, 40 minutes. But in this course, what I'm thinking is that maybe it's like a 10 or 15 minutes quiz. It's like a very simple quiz, only 10, 15 minutes kind of thing. So I don't worry much about the quiz. And here's a course schedule. We are right here the first week. And on the second week, or a little bit of third week, we're going to review some of the basic knowledge of signals and systems. Okay? And then later on, we're going to talk about some amplitude modulation, which covers a couple of weeks. And then we start to talk about angle modulation. So amplitude modulation and angle modulation, these two are the main part of analog communications. These are analogs. And hopefully, after midterm, we're going to start to talk about some of the digital communication. And we first talk about pulse modulation, followed by some digital modulation, random variable, and all these things. But these are the second half. From week 9 onwards, those are probably digital communications. Okay? All right, so these are some basic introduction of a horse. Any question about this? No, right? Okay. Okay, let's get started. Since this is a first course, what I'd like to do is I'd like to briefly introduce you about the background, historical background. So this is a very easy one, so it's just easy going. Okay, you don't have to remember anything. Just look at and just enjoy. Right? First thing is a telegraph. In 1844, you probably heard about the guy named Morse. This guy developed the Morse code, right, for telegraph. So he developed this one, and this Morse code is still being used. That's surprising that this is a very simple code, especially for military purposes, and in some of the applications, it's still being used. In radio, what is a radio? Basically, the definition of radio is like you are using this air as the medium. You are not using fiber or cable. Instead, you are using air as the communication medium, right? That's the radio. And also, you are using electromagnetic wave to do communication. So that's a radio. And radio has a very long history, such as in 1864, you probably heard about this guy, right? Maxwell, Hertz, all these things from high school physics, right? So these guys, some of the developed some theory and also some experiments on the existence of electromagnetic wave and also the possibility of using electromagnetic wave for communications, right? So after such kind of pioneering discovery in late 19th century, there was a lot of development, such as Marconi. In 1901, he demonstrated actual communication done over a long distance over the air. Right? And after that, you know, there are some another like super heterotime radio receiver was developed, and all those things in early 19th century. So in 20th century. So in the late 19th century and early 20th century, it was very popular to do research on the radio, and a lot of tremendous of job has been done during this time. How about telephone? In 1875, you heard about this guy, right? Graham Bell, and this guy first invented telephone long back, and then telephone also has its own advancement. And also electronics. I don't know if you heard about any of these guys, but some of you probably heard about this guy, Lee DeFrost. This is an American scientist, and he invented a vacuum tube. And this one was a very breakthrough at that time. And thanks to this, a lot of electronics had been developed. And later in 1948, in the Bell Lab, these guys developed what we call as a transistor. So earlier than this, everything was done by vacuum tube. I don't know if you're familiar with vacuum tube, but vacuum tube is like you have a filament in there, you have a vacuum, like some bulb, right? Like a light bulb. It is completely analog type. It is very fragile. It can be broken easily by high electricity. So it's very unstable somehow. But you can use this one to develop some good electric machine. But later, when this guy developed transistor, this was a really breakthrough, because thanks to this transistor, all the electrons can be now fit into a small size, right? One of my friends has a hobby of listening a very good classic music, and even now, right? There's a classic music audio system based on the vacuum tube. I don't know, some of you know. It's very expensive these days because it's very rare. It's very rare. Everyone uses this one, right? Digital circuit transistor. But vacuum tube is very fragile, very easy to break, but very expensive because of it's very rare. But someone tells that this one creates very perfect click sound. Actually, I don't know. I don't have that. So I never even tried. But someone told me, very expensive, but still there are some people who enjoy this one. But anyway, this is the real breakthrough that make a lot of progress on the electronics based on these digital circuits. And later on, everyone used a transistor. Television was also another breakthrough at this time. Okay? And also, after that, we are still using television. Digital communication also, it's almost started in certain early 20th century. You also heard about this guy name in digital signal processing course, right? Nyquist, right? And also this guy name in 1948. So all of these things is done in early 20th century, a lot of things. Computer networks is pretty recent. It's 1940, 50, 60. But this one also has been evolved based on its own track. And one of the things that you can see right here is 1971, you hear the Arpanet. This Arpanet, this is basically developed in US. But this is actually the ancestor of internet. We are using internet every day, right? It's all globally connected, cable-based internet connection. This one is actually ancestor of that. Actually, here it says that it probably was renamed the internet later. So this is also another very important track. So all of these things, actually another one, the satellite communication. It has its own track. Yeah, you can read that later. Optical communication also. So all of these different category has its own advancement during the late 19th century and early 20th century. A lot of things about this wireless communication are done earlier than 1950s or something. And around the 1940s, 50s, Bell Lab, which is in US, in New Jersey, they have a lot of research and development. And we are still using it like 60 years later now, right? Still using. And all of the theory, most of the theory that we learned throughout this book were developed at that time, like 50 years, 60 years ago, or even earlier. Okay? That's what we are learning. Last year, you learned electromagnetics, right? Remember that electromagnetic course? That's even like 100 years ago. All the theory are from Maxwell. And Maxwell, I think he lived in 1892 or something, right? It's about more than 100 years ago. So a lot of theory are based on such long history. Okay, anyway. Okay, now what we are going to look at is that some of the brief introduction of elements of communication system. So this picture shows you a brief introduction or overview of communication system. What is a communication? Communication is like there's one guy, there's another guy who are communicating, right? Communication basically means that you can probably communicate by words, verbally speak, or maybe you can communicate with a text message. There are many different ways of doing it. But all of these different type of communication systems have these kind of basic elements. So first element you can see is the source of information. What is source of information? This is the information that you want to deliver. And this is the information that you want to receive. So for example, let's say I want to make a phone call to my friend. So what is the source of information? And want to talk to him. And what is the source of information in that case? Voice, yes. You are basically talking, right? Whatever you talk, that's the information. And that information, whatever you're talking, is going to be delivered somehow to your friend. So in that case, this is going to be voice. Some other times, let's say you are using KakaoTalk. You just type text message. In that case, text message will be source of information. Maybe some other times, maybe you have a digital camera with Wi-Fi. There's some digital camera these days with Wi-Fi enabled, right, built in. So you took a picture and then maybe click to send it over Wi-Fi. then your friend receive the picture you taken. In that case, the picture or the or video can be the source of information. So that is a source of information. Typically, this source of information is analog. Why? The real information exists in the world is analog. Your voice, analog. You take a picture, that's analog, basically. You are using digital camera, but digital camera is actually capturing the analog snapshot and digitize it, right? Inside the digital camera, you digitize it. So original information is always analog, always. Now this source of information goes into the transmitter because we want to do communication, we want to send it. So this one goes to the transmitter. Now the transmitter makes this information into some other shape. Why? Because this is an analog information. You cannot transmit this one over the channel. In order to transmit something over the channel, now you have to massage this to change into a different shape. And that shape is suitable for transmitting over this channel. To do that, now we need to know what this channel we would like to transmit over. So let's say you transmit over wireless, okay, or air, or some other times maybe you can transmit over underwater. Think about submarine. Okay, think about submarine. Underwater, maybe you can communicate over the water, maybe, right? Or in the internet, your PC is connected with another computer over the cable. So in that case, the channel is cable, maybe copper wire. Okay, all different material, all different medium with all different characteristics. Air has its own different characteristic. Cable, copper, underwater, anything. All of the different channel has a different characteristic. So in order to transmit your original information over different channel, you need to make this information into different shape. To transmit over the air, you need to make it different. Over the cable, another way, or another shape, something like that, right? Because we are using different channel. Now, once you transmit over the channel, what this channel does is that channel basically distort your signal, distort your information. So your information somehow, now it's go wrong. You can sometimes have error, or you have a noise in here. After some noise and distortion, you receive it. And then based on the received information or received shape, now you are change it back to the original information. Let's say this is your original voice, then eventually going all this procedure, you want to recover the original the voice back. Okay? That's the whole procedure. All these things is a basic element, but out of this element, this information, this one, you know it, because this is the information you are transmitting. So this is your information. Of course, you know it, right? This one, you can control it, because you can make your own device, your own transmitter, and you can apply any algorithm or any processing, you can change it with your own. So you can control it, you can make it. Same here, receiver, you make it. These are pair, right? Right? Basically pairs. If you have a certain transmitter, we have a pairing receiver. So these two come together, and this is the information you recover back. However, this one, channel, you have no control, absolutely no control. Because air or copper cable, underwater, whatever happens in the channel, you have totally no control. You cannot control anything. You cannot do anything here. You have a noise by nature. You cannot remove noise, right? So you cannot do anything about it. That's why you need to have a certain processing in the transmitter receiver, because you cannot remove it, right? So we're going to talk about all these things. But the main focus of this course is to learn about these things. This one, we are not learning anything, right? This is out of scope. We don't worry about this. And we don't worry about this, but we're going to learn about this one and this one. And this one, little bit. This is actually very complex, and we need to know very well about this one. But we're going to talk about only a little bit about this one, some of the basic things. And some more details about this, maybe in the next course, digital communications or wireless communication, which is one of the graduate courses. So we are focusing on here, mainly. Okay? When you transmit some information, you need to use some of the resources. For example, channel, for example, frequency, or time, and those things. So we're going to talk about some of those things later. As a type of communication, first easy thing to understand is broadcasting. So what is a broadcasting? Basic definition of broadcasting is that there's one transmitter, but there are many receivers. I'm doing broadcasting. I'm talking, all of you are listening. That's broadcasting. Yeah? Single receiver and single transmitter, numerous receivers. But these receivers are not dedicated receiver. What that means is, if I dedicate receiver, what happens is that when I talk, I assign only a couple of them. Okay, you. Only you guys listen. Other guys do not listen. That's not broadcasting. That's the communication to the dedicated receiver. In that case, it's still multiple receiver, but that's not broadcasting. Broadcasting basically means that I talk, and I don't know who is listening. Anyone can listen. I don't know. Random receiver, you can just listen. That's broadcasting. In wireless, over the air, basically it's always broadcasting because I transmit, and based on this air, my voice can go anywhere. So anyone can listen. That's broadcasting, right? However, what about the cable? Cable is different, right? I only connect to the cable to him, and him, and him. Only 3 guys. And I talk, then only these guys listen, right? Because I have only cable connected only with these 3. If you are not connected with me with the cable, you are not listening. So that's a different type. But in the air, naturally it's a broadcasting. Like a television, for example, right? That's a broadcasting because they transmit the television signal over the air. So again, that's broadcasting. Another type, which is more popular type, is a point-to-point. What point-to-point means is one transmitter, one receiver. Point to point. That's a point-to-point concept. This is more popular. And when you look at the satellite communications, this is also point-to-point. Here's a point, here's another point. Transmitter, receiver. But in order to transmit the transmitter receiver with a very, very long distance, they are using the satellite. Right? They are using the satellite. In this picture, we need to remember a couple of different words. One is this word, uplink and downlink. Basically, link. What is a link? Link is a connection between transmitter and receiver. That's the link. And the basic connection, that's the link. So in this case, we have 2 different links. One link, transmitter, receiver. Another link, transmitter, receiver. That's the link. Okay? 2 different links. But we call this one as an uplink because it goes up. This is downlink because it goes down. And these words, uplink, downlink, are still used in cellular communication. Let's say you have a cell phone. Let's say you want to talk to your friend in Busan. Okay? So you make a phone call in cell phone. For example, like this. Then your cell phone transmit the signal to your base station. We have a base station somewhere here, right? Maybe somewhere here. So your cell phone send the signal to your base station. So what is that? That's uplink. Physically, in satellite communication, the satellite is up here, so that's why we call uplink, but the same concept still exists in cellular communication. Okay? In cellular communication, we call that as uplink. So somehow your base station is like up above our mobile systems. So you transmit uplink, right? And then let's say your friend send the information or want to talk to you, he talks something, then his voice eventually delivered to my base station and eventually come to me. And from base station to my cell phone, that's a downlink. So these are very common words. What I'm saying is that these two are not the words only used in satellite communication. These are also used commonly, very commonly, used in wireless communication and also mobile communication, cellular communication, everywhere. So remember these words. Okay? Your device is always low. Okay? Your device is low. Base station is always high. So you go up, you send it over, uplink, you'd receive it down, downlink. Okay? So remember these words. When we say communication network, typically we are talking about background or backbone network. What is a backbone network? Coming back to cellular system, let's say you have a cell phone. You want to make a phone call to your friend. So you press the button, phone number, and connect it and make a phone call. Then your cell phone generates electromagnetic waves, and that will be eventually delivered to your base station. And after that, now your base station is connected using cable into another base station, right? That's what we call as a backbone network, right? That's not wireless. The wireless is only from your base station to your cell phone. That's only wireless. After that, or internal, the base station network, that's a network. That's all cable connected. And here, the communication network sometimes means that one, or some other times, for example, PC here in this room. And let's say some of you bring your own laptop, bring your computer, we all connected by internet. So that's all communication network because it's all cable connected. In this communication network, we have two different types. One is a circuit switching, another is a packet switching. So this one actually is very important, very basic words. So you probably want to understand and remember these two words. I'll tell you the main difference. What is a circuit switching? It basically means a circuit, right? It's a circuit switching. The simple example of circuit switching is old telephone. Old telephone. So think about old telephone. Let's say in my home, I have a very old telephone like this, right? Cable, telephone wire cable. And then I want to talk to my friend in Busan, let's say. What happened is I pick up the phone and put the phone number, right? Press the buttons. Then using the cable, my voice goes to my public transportation. We call this a PTSN, Public Service Telephone Network. And then, or KT, basically, our house has a KT, a telephone station near my home, right? My phone is connected to that with a cable, telephone cable. And then from that KT office, it goes all the way to another KT office near my friend's house. And there, again, it's using another cable and then connected to my friend's home. So simply speaking, in the old telephone, in old telephone case, my telephone and my friend's telephone are actually cable connected. It's directly connected. Okay, it's directly connected. So whatever I say over the link, he will listen. Let me. Okay, let me draw a picture. Does it look like a telephone? Okay. I'm not very good at drawing. So let's say this is me, my home. Actually, this is a telephone in my home. So phone 1. This is another phone, phone 2. My telephone is connected to KT office near my home. My friend also, his telephone, all the telephone is connected with another KT office near his home. And internally this KT, another KT office, maybe it's all connected, right? We don't care. We don't care how these are connected. But anyway, internally in the KT offices, they are connected. In the circuit switching, what happened is when I pick up this phone, when I pick up my phone and try to make a phone call to my friend, then from this phone all the way to my friend's phone, this link is permanently set up. So this is what we call as a circuit. So this line is reserved because I use this telephone with him, so I reserve this one. So what that basically means is, think about this way. I called him and he picked up the phone, he received it. And we both, me and my friend, both, we just pick up the phone and say nothing. Just hold the phone without talking anything. For 1 hour, let's say. For 1 hour, no words, just holding the phone. Do you pay or not? Of course you pay, right? Because why is that? I'm not saying anything. I'm not transmitting any information. No information because I say nothing, right? No information, but I still pay. Because for that 1 hour, you didn't transmit any information, but you are using this line. You reserved this line for 1 hour, right? It doesn't matter you are using or not. You are actually using. It doesn't matter you transmit information or not. You reserved it. You are using. That's a circuit switching. Very old-fashioned, easy way to do it. That's a circuit switching. Another type is the packet switching. Let's talk about packet switching. In packet switching, what happened is now I'd like to change this one into computer. Like that. So I'm basically doing text messaging with my friend using a PC, using computers. Okay. So what is the popular chatting program? Nate? Kakao? No, in PC. Still Kakao? Okay. Okay, let's say you using Kakao over PC. Okay. So this is you, this is your friend. Now in this case, I opened my KakaoTalk and this guy, my friend, also is using KakaoTalk. KakaoTalk is here on the screen. I also have a KakaoTalk here. In this same case, let's say I don't type anything. I just watching it. He's doing same thing. Doesn't type anything, just watch. Do we pay or not? We don't pay. Why? Because no information is going. what's the difference between the previous circuit switching and this one? Yeah. Well, one difference maybe you can say the previous one is a voice and this one is a packet. But this one is actually text message. But that's not the difference. Okay, that's not the difference. Difference is that the reservation, as I said. So the previous circuit switching, you are going to reserve it. You're going to reserve the link. So it doesn't matter you use it or not. As long as you reserve it, you have to pay. Because no other people cannot use it, right? Because you reserve it, you cannot, the other people cannot use it. In this case, this is a packet switching, so other people can use it. Let me tell you how this works. In the packet switching, everything is done by packet. That's why we call this packet switching. What is a packet? So basic definition of packet is that you have a certain data, group of data. We call this one as a packet. Every packet has a header. This is a header. And then actual data. We call this a payload. Right? Payload. So your actual data goes into payload. This is your data. Maybe this can be payload. This can be a text message over KakaoTalk. Or maybe sometimes this can be your voice. Whatever information you have, it doesn't matter. The information you want to deliver, that's a payload. Then what is a header? This is not information. Then why do you need this? Yes. The reason that you need a header is because this is a packet switching. Now, let me tell you this one. Let's say, think about a mailing system. Mailing, not email, but let's say you write a letter to your friend, very old-fashioned. Write a letter by your hand, and you want to deliver to your friend. First way is that maybe you can reserve a, that really doesn't make sense, but let's say you can reserve some pipe or some way to your friend. And you write a letter and put it into the pipe, then it goes to your friend. That doesn't make sense, but that's kind of reservation. That's kind of circuit switching. What is a packet switching is that you write a letter to your friend. And that letter, which is payload, how do you do it? You put the letter and put the letter into envelope. You write a letter. This is your letter. And you write this, you put this letter into envelope, right? Envelope. Put it into here, right? This is envelope. And then what do? In this envelope, you write down the destination address, your friend's address. If you didn't put their address, then nobody knows where this can go, right? So you put this letter into the envelope, and outside the envelope, you need to write down destinations or your friend's address. Exactly same thing here. Your original letter is the same as a payload. This payload is contained in the packet. This packet is like an envelope. And this envelope should have a destination address, which is header. So this header, actually header has many information, but the most important information is the destination's address. So you put your destination's address into the header. So the whole thing is exactly like your letter. In that case, let me ask you a question. Let's say you write a letter and put it into envelope, and you write down your friend's address. And then what do? Do you bring this and run to your friends? No, right? What do? Put this one into? Put this in the post office. That's it. And after that, maybe this one goes into, let's say your friend is in Busan. Maybe this one goes to Daegu, anywhere, right? You can go anywhere, but I don't worry about it. Maybe it can go to this way, that way, many different ways, right? But I don't care. What I care is that he received it or not. How this goes doesn't matter, right? Exactly same thing here in the packet switching. In the packet switching, I make a packet and I have the destination address here and then transmit. This packet I transmit. And I don't care. Actually, if I write it a little bit more complete, maybe I have one KT office here, another KT office there, maybe another one KT here, some other one here. Maybe there are many different routes, right? Many different routes. When I send this packet, sometimes this packet can go this way, or sometimes this one can go this way, or another way. But I don't care. As long as my letter goes into destination, I'm fine, right? I don't care. That's the packet switching. That's the packet switching. So now, which one is more efficient? This is much more efficient. And these days, we don't have this anymore. This is very old way, like a telephone network. We are still using old telephone, but these days, not many people are using old telephone. Everyone is using cell phone, everyone is using packet switching kind of communication system, because this is much more efficient, much more efficient. And why the packet switching is better? Because here's the thing. Now think about the reservation system, circuit switching. Okay, circuit switching. Now you reserve this line, and let's say there's some there's some fire somewhere. Just think about it. There's some fire, so this line is broken. This is disconnected. In that case, you are losing everything, because physically this is disconnected. You are losing everything. But in packet switching, it doesn't matter. If something is wrong in this link, you can always go into another way. We call this a D route. Okay? You can always go another way, no problem. And if there's a lot of traffic here, you can go another way. So this is very efficient. And every day, these days, you can say that pretty much all of the communication network we are using is packet switching. Okay? And that's the main difference. Okay? So important to know. Okay, here's one. Let's say this is the source. Source is who is transmitting. So this is source, let's say. And let's say this is a destination, my friend. Circuit switching is like we are reserving. Okay? We probably reserve this line. That's circuit switching. Whereas packet switching, I just make a packet and put his address and just throw it. It doesn't matter. It goes this way, that way, that way. It doesn't matter. Okay? As long as he receives it, that's okay. Then it looks like a packet switching is always good. But sometimes circuit switching is better. In what case circuit switching is better? Okay. Why is that? Why in voice application circuit switching is better? Why? That's actually true. Why is that? In voice communication, this one probably is a little bit better. Why? Yes, but there's important thing here. Let's say I want to talk to him over the phone. And think about packet switching. You can still use packet switching because payload can be your voice. Always, we can do that. We can do that these days. Let's say I'm doing some Do you have any PC program that do some conference? Yeah, it's like a Skype, right? You run the Skype using packet switching. You talk to your friend and your voice is digitized and go into the payload. Now the Skype makes a packet and transmit. Okay? It's basically the same thing, but in that case, what can happen in packet switching is that you transmit your voice. And sometimes, if you're unlucky, packet can go into that way. It probably takes like 10 minutes. In that case, I just said, but my voice is delivered to him after 10 minutes. Then it's nothing, right? So that's why some of the applications is very sensitive to delay. Delay is a very important metric. If you are worried about delay, typically voice is very sensitive to delay. If I say now, and 1 minute later he listens, then nothing. That means nothing, right? So such a kind of application, sometimes this is better. Because this one, you reserve it. It is guaranteed that as soon as you talk, he listens immediately, right? So in that case, this one is a little bit better. This one, there's no guarantee. Sometimes very much delay is possible. Yeah, okay? But as I said, efficient-wise, this is much, much more efficient. So these days, everyone is using this one. Maybe you can see the internet telephone these days, right? IP phone or internet telephone. That's all based on this. And it's cheaper, right? Cheaper. Yeah. Why? Because you are not reserving. You don't reserve it, right? You basically share with everyone. So that's why. Okay. There's also words like a data network. It's basically the same thing, so almost similar. Computer networks or communication networks. But when you talk about networks or communication, there's a concept layer. There's a concept layer. This is actually a very important concept. And I believe that the knowledge of layer probably is beyond this course because there are quite many things to talk about. But simple thing that you want to remember is that there's an organization called OSI, Open System Interconnection. This is an organization. And this organization, they actually set up a certain level of layers. That's what we call is OSI 7 layers, which is this one. So this is a name of organization, and they said that every communication system we can categorize into 7 different layers. Every communication system. Maybe some system has 4 layers, some other system maybe all 7 layers, but anyone can have 7 layers, right? There's nothing with 8 layer, 9 layer, 7 layers is enough. So we have different layers, but mainly we are going to cover first layer in this course, which is physical layer. Second is a data network or data link layer, network layer, transport layer, session layer, presentation layer, application layer. All these layers have its own, it's own job. It's very different, each layer. Okay, so it's a lot of things to talk. But remember that in this course, we are mainly talk about physical layer and sometimes the second layer, which is data link layer. So we are only looking at these layers, okay? These layers. Maybe some of you heard about TCP/IP, right? So let me give you some simple example. The highest layer, the uppermost layer is application. So let's take an example just to help you understand. This one is something like a KakaoTalk. You run the KakaoTalk. That's application. So you run the application, KakaoTalk in this case, and internally in KakaoTalk, it basically, whenever you type in some text to your friend, it actually creates TCP/IP packet. your information, your text message is going to the payload, and then with that as a payload, that program generates the TCP/IP. This transport layer is related to the TCP. TCP is the protocol, and TCP protocol belongs to this transport layer. IP is another protocol that belongs to network layer. So when you say TCP/IP, that basically means these two layers. So your original application, you get some text message, and then this application creates a TCP/IP packet, which is here, and then that TCP/IP packet now goes into the cable, and it's connected. It goes over the wire, something like this. Okay, something like that. So we have a computer network course, right? Later. We're going to look at much more detail about these things in that course. Okay. This one, I think we can skip it because we know the voice over IP. So voice over IP is like a Skype, right? You have a voice, but that voice goes over the IP network. How does it go? Like this way. Your voice goes into the payload, and then using the packet, and this packet is a TCP/IP packet as an example. I just said header, but this header can be TCP header, or it can be IP header. In that case, this whole packet is called the TCP/IP. So some type of form, some kind of packet, it goes into the network. So that's a voice over IP. Okay, so let me move on here. Okay, in this slide, what we are trying to talk about is that when you do some communication, we always use two different resources. One is a power and one is a bandwidth. And the reason that we are talking about these two is something like this. Let's say I want to talk to him. That's a communication. What's a power? Transmit power. It's how high I talk. That's a transmit power. Sometimes I can whisper, like small voice, right? Sometimes like I can scream. That's a transmit power. So apparently, if I increase my voice, he can listen much better, right? Maybe if I reduce my voice, then the guy in the back probably cannot listen. So simply speaking, if I increase the transmit power, communication is better, simply, right? What about the bandwidth? If you increase the bandwidth in frequency domain, you can deliver more information. It's like a straightforward, right? So generally, we are using these two different type of resources. But in the channel, actually, there's a certain region we call as a power limited channel, and there are certain band limited channel. We're going to talk about this one probably later when you have a chance. Okay, let me skip that. We're going to cover this one later. This one says underlying theory of communication. So these are the main thing that we're going to cover in this course throughout the whole semester. One is modulation theory. Okay? So throughout the whole course, you're going to hear this word many, many times, modulation. Many, many times. A lot of times. So you need to know exactly what this modulation means. Okay? And there are many different types of modulation. If you remember the course schedule, okay, the course schedule, 16-week course schedule that I showed you earlier, you see that amplitude modulation, angle modulation, digital modulation, there are a lot of modulations there, right? So all of those things are modulation. So you want to remember the definition and what kind of modulation you have and how to do it, okay, all those things. These are some of the related explanation about modulation theory. But before moving on that, then let's briefly talk about this word. What is a modulation? Does anyone know? Change of. So to do that, I'd like to go back to this. You start from here. You have your original source of information. right? And modulation is actually done here. Here is where modulation is done. And why do you do modulation? And when yeah, right. But if you want to transmit long range, maybe you can increase the transmit power, maybe. Then it goes very far. So the main reason that you do modulation, actually modulation is a transform. You have your own source of information. Maybe it can be voice or it can be audio, signal or anything. And you want to transform or massage this signal into another shape. That's a modulation. So modulation is basically changing or converting one type of signal into another. Then why do you change it? Why do you convert your information into another one? Because we need to transmit that into the channel. Okay? We need to transmit that into channel. This channel can be any channel, right? But if you transmit original information without modulation, with no modulation, then maybe you can transmit information maybe just 1 meter because of this channel, right? So since our channel has a certain characteristic, certain medium, there's a certain type of shape which goes through this channel much, much better than your original signal. So for example, right, in the air, over the air, what is the most efficient way of transmitting? Sound, yeah, sound, but what is the physical characteristic of this air such that what kind of shape, what kind of signal is better, is the most efficient to deliver? It's like a sinusoidal signal. In this air, like this kind of medium, if you transmit some weird shape or some rectangular shape or something like that, it does not go far. Electromagnetic wave goes very far. It penetrates very, very good in this air. Okay? So every channel has a different way, different type, different characteristic. So the modulation is necessary in order to change this one into another shape, and that shape is the best suitable for this channel for communication. So that's the modulation. Okay, that's the modulation. Yeah. Okay, so we'll move on a little bit. We're going to learn the Fourier analysis and some frequency domain description and representation later. Okay, this is very important for analyzing and looking at the performance of the communication system. So we're going to cover this one later. And as I said earlier, probability theory and random process. This is a very, very fundamental theory, mathematical foundation behind this communication theory. So we need to also cover these things. Detection theory is what's happened in the receiver. So you transmit something, and at the receiver, you need to recover it, or you need to detect it. So in order to detect, it's very difficult to do it. A lot of theory is in there, so we also need to cover some of those things, right? This is some aspect of receiver. Okay, so that's some very brief description of what we're going to cover throughout this whole course. So all the single details, every details, we're going to cover probably from next week. Next Wednesday, right? And these are the assignment. As I said, I want to review some signals in system because we keep using some convolution or some frequency time relationship and some of the basics of signal system. We're going to look at it many, many times. So throughout this course, probably Wednesday and next week, we're going to cover and review some of these things, but at the same time, you can do that by yourself. Okay? because we don't have enough time to cover everything. All right.